Hey everybody, welcome to 4-Minute Physics. In today's video, I'm going to talk to you about nuclear radiation and its properties. Again, the aim is to do this in under 4 minutes, so we'll start the timer and see how we get on. Okay, nuclear radiation is produced from unstable elements and atoms. The aim is to become more stable, so they release radiation in order to try and achieve this. There are 4 possible ways this is done. There are 4 different types of radiation. The 4 are alpha, beta, gamma, and the neutron. There are symbols that go with these, of course, as well that you need to recognise. Alpha, beta, gamma, first 3 letters of the Greek alphabet, and the neutron, just a lowercase n. Radiation is harmful, so exposure to radiation can cause damage to tissues and cells. The reason for that is that it is ionising. Ionising means it has the ability to turn atoms into ions. And if there's an ion, that ion is likely to be involved in some form of chemical reactions. And if that's going on in your cells, that's not a good thing, because those chemical reactions might not be the correct chemical reactions that should be taking place. This can damage DNA and lead to things like cancer. The other effect of high exposure to radiation, all in one go, would be radiation sickness. Now, low amounts of exposure, small doses, aren't necessarily harmful. Our bodies, in fact, are used to small doses of radiation all the time. We get radiation from the rocks beneath our feet, from space, from the air we breathe, even from some of the food we eat. I'm not trying to scare anybody here, I really am not. But radiation in small doses is not necessarily anything to be worried about at all. It's when you get exposed to large doses of radiation that you need to be worried. And in school, if you're using these as a demonstration with your teacher, the amount of dose that you will receive from that experiment is absolutely tiny. But we still have to be safe. We still can't mess about with these things. They are still dangerous. So we must handle them correctly, and we must use the right health and safety protocols. The symbol for radiation is this symbol here. Doesn't always come with caution radioactive, but that is the symbol, and you need to recognise it. We can detect radiation using a variety of different tools. The most common that you might use in school would be a GM tube or a Geiger-Müller tube. And again, it's using the effects of ionising to create a little electrical discharge inside the tube. This is then measured by the counter behind it and goes beep, 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 beep. So, let's have a look now at the 4 types of radiation. First of all, alpha. So, an alpha particle is made of 2 protons and 2 neutrons. This is emitted from the nucleus. Therefore, it has a charge of +2, and it's highly ionising as a result. Doesn't go very far though, only goes about 3 centimetres through the air. So really, unless it's really, really close to you, or you breathe in any elements that produce alpha particles, there isn't a massive amount of risk. It can even be stopped by paper. The next one is beta. Beta particles are electrons. Again, these are emitted from the nucleus, and that's something I'll explain in another video later. But these still have an effect of ionising because they have a negative charge of -1. They do go a bit further because they are a lot smaller, so they can go about 30 to 50 centimetres in air, and they can also be stopped by using about 3 mils of aluminium. Gamma, well, gamma is not a particle. Gamma is a ray of electromagnetic radiation, and we often refer to these things as photons as well, so gamma photons might be a term that you might need to recognise. It is ionising because those photons are high energy, and therefore they can cause damage to cells. They can also travel huge distances, and they are incredibly hard to stop, needing lead and concrete. The last one is the neutron, which takes place in fission reactions and is released as part of that process. Whew, well, my word, that was right down to the very last second, but we've just about managed it. So, I hope that was a useful recap on to understanding nuclear radiation, and please join me again next time for another video on half-life. So, thanks for watching. See you soon. Bye.